This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to look at matrix multiplication. In section 1, we're going to do a dimension check so we can determine which matrices can and cannot be multiplied together. In section 2, we're going to run through an actual example. Okay, let's get started. So the first thing we have to consider for matrix multiplication is dimension. So what are the dimensions of a matrix? So let's take, for instance, a matrix that have the size. Now I'm not actually putting in numbers in this matrix, so imagine that these dashes represent values. So those are all numbers there. Okay, so let's just pretend for a moment. What you need to know for matrices is the difference between rows and columns. So rows go horizontally. So there's 2 rows here. Now let's talk about columns. There are 3 columns, and columns are vertical. And the way to help remember that is when you look at those old, ancient, historic columns from Greek architecture, you remember that columns are holding up buildings. So columns are always vertical. Okay, so that definitely does help if you get that mental image in your head. Okay, so this particular matrix is a 2 by 3 matrix. That's not an X. That's like 2 times 3. So think for the cases of dealing with matrices that's not an X for the moment. All right, so there's 2 rows, there's 3 columns, and let's say we're going to multiply it by another 2 by 3 matrix. Okay, so we have another 2 by 3. You know, if we were talking about addition and subtraction of matrices, you know, this would be great. You could add these 2 matrices together, you could subtract these 2 matrices together because they're exactly the same dimensions. But the problem with matrix multiplication is that it doesn't work. Okay, and you know how easily I could check is just by looking at these 2 numbers right here, 3 and 2. They have to match. So in other words, the columns of the first matrix has to match the number of rows of the second matrix. Otherwise, it's not going to work. Okay, so that's an easy check to do. Now, if we were actually going to multiply these 2 matrices, we would, if you try plugging these into a calculator, it's going to give you an error, and it'll probably say something like a dimension error. Okay, so why doesn't it work? Because when you actually multiply, you take this column and you multiply it by this row, and you can see that there's just not enough numbers to match. I've got 2 numbers here, I got to multiply by 3. Okay, it doesn't work. The number of numbers here have to match the number of numbers here. In other words, those 2 sets of numbers have to match. All right, that doesn't work. So let's take a look at an example that does work. So I'm going to get rid of all this. Okay, let's start with another set. All right, let's say we had a 3 by 2 matrix. Okay, so in other words, we've got 3 rows, 2 columns. And let's say we multiply it by a 2 by 4 matrix. Okay, what does that mean? Okay, so this is 3 rows, 2 columns. This is 2 rows, and of course there's 4 columns here. Now it turns out that these are multipliable because these 2 inside numbers match. All right, great. So now we can see that these match because these 2 numbers fit those 2 numbers exactly. So the column here, which is, there's 2 numbers in this column, right, because there's 2 rows here, and I've got 2 values in this row. In other words, they'll fit. It exactly fits for multiplication. All right, so now since these 2 numbers match, that tells us that I can multiply them. If I was wondering, if I do actually multiply these 2 matrices together, what's going to be the new size of the matrix? Well, that's really easy to determine also. You use now the outside numbers. So I know that the size of this matrix, once I do multiply them, is going to be a 3 by 4 matrix. In other words, if I put the answer down here, I know that there's going to be 3 rows, and I know there's going to be 4 columns. So this is how big the matrix is going to look once I'm done multiplying them. Okay, all right, so let's actually take in our next section, we'll talk about how to actually carry out this multiplication. So we're going to walk through an example of how to multiply matrices, and let's take a case where we're dealing with this matrix. Let's say this is a 2 and 1, a -3 and a 5. And let's say we're going to multiply it by this matrix, which is a little bit bigger. 1, -1, 4, 0, 0, 2. It's a little small. Let's make that guy bigger. Okay, so we're multiplying these two matrices together, and the first thing you should always do when you're being asked to multiply two matrices is to do the dimension check. So that's what I'm going to do. So the first thing is you look at this matrix and you'd say, yep, there's 2 rows and there's 2 columns. 2 by 2 matrix. Over here we can see that we have a different size matrix. This one has 2 rows also. Remember, rows go horizontally. And this one has 3 columns. Okay, so I'm taking these 2 matrices and I'm multiplying them together. Can you do it? Sure can. Look at those 2 inside numbers. The inside numbers are the same. So that tells us that yes, you can multiply these 2 matrices together. Let's talk about the size of the answer. So when we do multiply these 2 matrices, we're going to get a matrix answer. What are the dimensions of the solution matrix? Okay, I'm trying to choose my vocabulary carefully. Well, you use the outside numbers. So I know that this matrix is going to be a 2 by 3 matrix. So that means it's going to have 2 rows and it's going to have 3 columns. Okay, so it's got 2 rows and it's got 3 columns. All right, now let's talk about the algorithm necessary for us to multiply the matrices. All right, so when we do these problems, we're always going to take the rows of this matrix and we're going to multiply it by the columns of this matrix. Okay, so let's actually take a look at how that works. So let's take the first row here. So we're going to take 2 and 1. And we're going to multiply it by the column here, 1 and -1. So I'm just going to place 1 and -1 right next to those numbers. So you find the product of these two, product of those two, and then you find the sum. Okay, so the sum you can see is 1. And I'm going to put this sum right here. Why? Because remember, this was the first row, first column. This is the first row, first column. So it's going to go right there. Okay, let's get rid of all these dashes. Okay, so I'm going to put that value of 1, right? So our answer here is 1. Let's put that 1 right here. Okay, so we're going to find the other values and we're going to use the same process. Now I went a little slowly. I'm going to pick up the speed. Okay, I'm going to get rid of all this workspace. Okay, let's continue. So to get this next number is in the first row, second column. So I'm going to go to the first row, and I'm going to go to the second column. Okay, so what do? I multiply, I add, and I get 8. 8 is the solution, so that's why 8 went in there. Okay, so that's the next number. Let's clear the space. Okay, let's resume. So in our next value, you can see here it's the first row, third column. First row, third column. So let's go to the first row, 2 and 1, and let's go to the third column, 0 and 2. Multiply, multiply, add, you get 2. Okay, let's clear the space. And now we resume. So let's go to our next one, which is going to be our second row. And let's go to our first column. Okay, so we multiply, find that product, find this product, and now we add those numbers together. So if I add, I'm going to get -8. Okay, so let's clear the space. Okay, so we're now going to go to the second row, second column. Second row, second column, find our products, find the sum. There you go. Okay, let's clear the space. Let's resume. So we're going to go into the second row, third column. Second row, third column. Okay, so we multiply, find the sum. That's 10. And there you go. Okay, so now we have the solution matrix to this multiplication of those matrices. So go back to MATHguide.com, check out our text-based lessons, our interactive quizzes, and our instructional videos. Take care.